Hi everyone, in last video we have gone through problems regarding this KCL and KVL, and in this video we are going to learn about mesh analysis. In order to know mesh analysis, firstly we have to know what is meant by mesh. Hope everyone of you know. See, this is how your mesh looks like. So in a similar way, if you observe these diagram, here you have three meshes, right? This, let us suppose this to be a mesh 1, this to be mesh 2, and this to be mesh 3. And in order to solve a problem using this mesh analysis, you have to consider individual current in each of this mesh. So let us suppose the current in this mesh 1 as I1, in this mesh 2 as I2, and in this mesh 3 as I3. And I recommend you to assume the direction of these three currents in a same way so that you may not get confused. It will be easier while you solve this question. Okay, you can assume of like however it is possible, but I recommend to consider all three in the same direction, okay, so that you may not get confused. And you have to give naming for this mesh. Okay, so let us suppose this to be A, B, C, D, E, F and Z. You can give name as your wish. Now we are going to apply KVL to the each of the mesh. Now let us suppose we take this mesh 1, that is A, B, E, F, A, and now we have to apply KVL on this mesh A, B, E, F, A. See, either you can start from here, here, here or here. Okay, so here I am starting from here, as since your current direction is in this manner, that is in a clockwise, while it comes to here your current direction is in this way, right? And we have already discussed that current always moves from positive to negative, and according to sign convention, if it is from positive to negative, we have to consider our voltage to be negative. Since we know that V is equal to IR, at this R1 resistance our voltage will be I1 into R1, but since we are moving from positive to negative, it is negative sign, so minus I1 R1. And now after this R1 we have to go through this R6. Previously when we have solved question in a general method, we have assumed only this as a single loop and only like I1 current is flowing through this, but in mesh analysis we should not do in such way. See here, this R6, through this R6 your I1 and I2 both are flowing, right? See, redraw this R6 here. See, it is your R6. So through this R6 your current I1 is moving like this. It means it is moving downwards, and your I2 is moving in this way. It means it is moving upwards. Hope you have got clarity about this. So now let us suppose I1 to be a higher current and I2 be a lower current. You can assume as of your wish, but I am considering the first one to be always higher, so it will be easier for us. Okay, now the total current through this R6 resistor will be I1 minus I2, since this R6 resistor is a combination of this current I1 and then I2. Okay, hope you have got clarity. And again, since we are moving in this way, see, through this mesh we are moving in this way, right? And we know that our current always moves from this current is now I1 minus I2, and since we know that current always moves from positive to negative, our sign convention should be negative, right, as we have discussed previously. So it will be minus I1 minus I2 into R6. And again, while coming to this resistor R4, see, again this R4 resistor we have two currents involved, that is I1 and I3. And as now if you see this direction, your I1 is in this way, and if you can see your I1 is in this way, that means if you redraw the circuit, your I1 is in this way and your I3 which is flowing like this, right? So this will be in this way. Okay, this will flow through like this, right? So this I3 will be in such manner. Now hope you have got clarity like how we are writing this current and this resistor, which is a combination of two currents. That means when both the currents are involved. So now your current will be I1 minus I3. Okay, as I have said you that consider the first one as the higher one and the next one as the lower, so we take I1 minus I3. Now your current through this R4 is I1 minus I3, and again since we are moving from positive to negative, it will be minus I1 minus I3 into R4, and since here we are moving, this short one is your negative terminal of a battery and this long one is your positive terminal of a battery, and since here we are moving from negative to positive, it will be positive according to this sign convention, so plus V1 is equal to 0. And as now by calculation, if you take I as a common, then you will get that is, if you take your I1 as common, then you will get R1 plus R4 plus R6 minus this I2 into R6 minus I3 into R4, which is equal to V1. You can solve this by your own, right? And this will be your equation 1. And if you take this mesh, that is B, C, D, E, B, so if you can consider these mesh, again you have to as we have assumed our current direction, that is I2 in this way, that means it will flow like this. Okay, now your I2 is entering in such way, so as again it is moving from positive to negative, voltage here through this R2 is minus I2 into R2, and again since here we are moving from positive to negative, it is again minus V2, and since here again we have R5 resistor, which is a combination involving of current I2 and I3, right? So as we assume I2 as the higher one and I3 as the lower one, okay, see, this will be your R5 resistance, right? Now your I2 current is in this way. See, your I2 current is in this way. Hope you can see. And your I3 current is in this way. So your I3 current is in this way. Now the current flowing through this R5 is I2 minus I3. And again since we are moving from positive to negative, it will be minus I2 minus I3 into R5, and again R6. Already we have come to know the current to this R6, that is I1 minus I2, which is in this direction, that is positive to negative, but here we are moving in this direction, that is from negative to positive. Since we move from negative to positive, we take as positive, so plus I1 minus I2 into R6 is equal to 0. And again on rearrangement, that is by solving, we'll get minus V2 is equal to minus I1 into R6 plus I2. If you take common, you will get R2 plus R5 plus R6 minus I3 R5. So here I am not making all this calculation because you can as this was simple and I wanted to make a video to be very concise way, I was not explaining all those. And if you take this mesh, that is FDG, that is, oh, here I have missed E, right? FEDGF. Okay, if you consider these mesh, again you have to consider the direction of this current. And if you see this through this R4, let us start from here. Through this R4 resistor, your current flowing is, we have already found that it is I1 minus I3, right? Now as this this current is in this way, but we are starting from here, which means as we are moving from negative to positive, according to sign convention, it will be positive. Hope you are getting connected to my point. That is I1 minus I3 into R4. Again, while coming to this R5, it will be again positive, since we have considered in this way. Previously I have explained that, right? But we are moving in opposite to that. That means from negative to positive, it will be positive again. And the current flowing through this R5 is I2 minus I3. So plus I2 minus I3 into R5. And again since here we are moving, see, we are moving in this way, okay? And since we are moving from negative to positive, it is again positive. So plus V3. Oh, I forgot to write this V3. This is your V3, okay? And since we are moving like this and the current direction is from positive to negative, it will be minus I3 into R3, which is equal to 0. We know that current flowing through this mesh is I3, right? So hope you have got clarity about how we have written these three equations. And if you have any doubt or if you find any difficulty in finding in writing this equation, please go and watch my previous video. There I have explained you very detailedly how to write this KCL and KVL equation. Okay, and on rearranging this, we get V3 as in this way. Now if you can see, here we know that V is equal to IR, right? So if we can write these three in the form of a matrix. Now let us write this. Here you have V1, that is plus V1, and here you have minus V2, and here you have V3. And if you can see, then here you have the coefficient as, see here these three equations were in this form, right? That is x1 plus, see you have gone through system of equations, right? a1x plus a2y plus a3z, which is equal to some constant, let us suppose it to be a, and b1x plus b2y plus b3z, which is equal to b, and c1x plus c2y plus c3z, which is equal to c. When you have in this way, we will write ax is equal to d, that is in argument form, right? We'll write this constants represents d, and this unknown values x, y, z represents your capital X, and the coefficient of this x, y, z represents this matrix, A matrix. Okay, now as since your constants here are v1 minus v2 and v3, you place this here, and the coefficients are since it is in the form of a1x plus a2y plus a3z, here your coefficient will be r1 plus r4 plus r6, here minus r6, and here minus r4. So in the same way, if we write here, we have where is this equation 2? Minus r6, r2 plus r5 plus r6, and then minus r5, and here minus r4 minus r5, and then r3 plus r4 plus r5. And the unknown values here are your currents, right? So I1, I2, I3, just simply compare this with this. Okay, now it is in the form of V is equal to R into I. This is nothing but Maxwell's mesh equation. We call this as Maxwell mesh equation. Instead of writing these three KVL equations, we can directly write this Maxwell's mesh equation, and I'll explain you how to write this. See, it is very simple. If you see, as we have considered this I1 direction in this mesh, see in this way, right? So since we are moving from negative to positive, our voltage will be positive, right? So it will be plus V1. Here you have plus V1, and if you can see this loop, here your current is in this way. Here you are moving from positive to negative, so your voltage should be negative, so minus V2. But if you can see, your current direction is in this way, you are and here it is from negative to positive, so it is plus V3. Hope you have understood. And now you may get doubt, then how do we get this? See, if you can see, normally in matrix we represent this as A11, this as A12, and this as A13, right? So if you can see A11, here you have to consider this mesh 1, the resistances involved in mesh 1. You have to add the resistances which are involved in mesh 1. What are the resistances involved in mesh 1? That is R1 plus R4 plus R6. So your A11 will be the resistance involved in mesh 1, that is R1 plus R4 plus R6. This is your A11. Now this is your A12. That means the resistor which are common to this 1 and 2, which is nothing but your R6. So it should be written in with the opposite sign, that is your minus R6. And if you can see, this is your A13 element, right? That is the resistor common to this first mesh and third mesh, which is R4. So minus R4. And if you take this is your A21, this is your A22, and this is your A23. And again in this A21, that is resistances which is common to this mesh 2 and mesh 1, which is nothing but your R6. So minus R6. Whatever you get here, you will get here. Whatever you get, see, whatever you get here, you will get it here. Whatever you get here, you will get it here. So simply write minus R4 here. And coming to this A22, the resistance is involved in this loop, that is R2 plus R5 plus R6. And now A23, the resistance which is common to 2 and 3, which is your R5 with minus direction, so minus R5. And here you have in this A31, that is common to this third one and first one, which is nothing but your R4, so minus R4. And now this is your A32, the mesh which the resistor which is common to this third mesh and the second one, which is nothing but your R5, so with negative sign, so minus R5. Next, the resistances which are involved in this mesh 3, which is R3 plus R4 plus R5, R3 plus R4 plus R5 into what are these unknown values here? We have I1, I2, I3, right? So I1, I2, I3. So in this way, we'll write this Maxwell mesh equation instead of solving all this. And let us see a problem on how to write this Maxwell equation directly with the help of a numerical. But as the video is being lengthy, I'll make a separate video on this problem. Thank you for watching, and subscribe my channel for more videos only if you like the content. And if you have any doubts regarding this topic, feel free to ask me in comment section, and I'll definitely respond to each of your comments, and let me know whether to continue this series or not. Thank you.